Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farhan bin Azir, MH1186. Alright, our group will do experiment about 2-degree freedom automobile simulation rig. Okay, our objective of this project is to determine stiffness, incorporate experimental value with the theory of the natural frequency. Next, we want to investigate the natural frequency effect towards the RPM.
Assalamualaikum warahmatullahi wabarakatuh. My name is Luqman, MH11082. Okay, today I want to explain about equipment for our experiment. Our experiment, as we know, is 2-degree freedom automobile simulation rig. So we have this blade for mass and 4 spring, motor, and we call mass, laptop, DAQ, sensor, and motor adjuster. So in this experiment, we have 3 sensors. First of all is tachometer, our sensor. This function to use to display our rotational velocity of motor. And then the second function and second and third sensor is this and this is used to display our acceleration data. And motor is used to generate vibration at this place. And our adjuster is used to adjust our motor velocity, angular velocity. Okay. The EQ is used to get the data from the sensor, and the EQ will transfer the data to the laptop, and the laptop will display our data. Okay. In our first experiment, we use this mesh to calculate the displacement of spring, because we want to calculate the what we call the stiffness of spring. So we use mesh and vernier caliper, and we calculate Ks, the stiffness. That's all.
Okay, my name is Hisham Abdul Aziz. Entry number MH11046. Next, I will introduce to you about the procedure, how to get the first objective of the experiment, which is we want to determine the stiffness of the spring. So, in order to the stiffness of the spring, we use this, the weight to place on the spring. So after we place the weight, and then we calculate, we measure the elongation of the spring by using the vernier caliper, and then we increase the weight with 40 Newton, and then we measure again using the vernier caliper, and then we increase the weight to the 60 Newton, and then the same procedure we repeat until 100 Newton. So the result for the elongation we can get in the report. That's all. Thank you.
Hello, for our second experiment, which is effect of RPM towards natural frequency. Here is just a simple experiment, which is adjust the RPM here, which RPM we need, and then we using the tachometer, and then we calibrate with the DZ-led, and we take the natural frequency, which is excitation frequency. That's all.
Okay, my name is Muhammad Aiman bin Umar, MH11019.
Okay, next I will explain about the DesiLab, the software of the measurement to calculate the parameters. Okay, for the first, we must set up the parameter on this software. First, we set up the sensitivity of the sensor, accelerometer and the tachometer. Okay, and then we must to synchronize the parameter on the DesiLab. Okay. On the first step, we use the digital output on the device. So we collect the 3 channel. On the first channel is the accelerometer sensor, and both channel, and the second channel is the tachometer. So for the accelerometer, the sensor collect the data to measure the acceleration. So we need to filter the input, and we use the YT chart to show the pattern of the wave of the acceleration. Then we differentiate the input, and we can get the velocity, and again we differentiate, we can get the displacement as shown. For example, this is the acceleration analysis. For the first, we can get the acceleration analysis because we know the input we get first the acceleration, and then second one, after in differentiate, we can get the velocity analysis, so we can get the natural frequency and the RPM. This is the displacement analysis, and we can get the graph, and also we can get the natural frequency. And then this is the worksheet. We use the FFT here to know the natural frequency, and we get the value. We get the value for the both natural frequency, and this is the signal for the sensor 1, and this for the signal for sensor 2, and this value for natural frequency 1 and natural frequency 2. This is a graph after we use the FFT to get the value of the natural frequency.